Hello everyone, welcome to today's presentation and thank you for attending. My name is Tayen Aguilar and I will be with you for the next couple of minutes to talk about how you can make much easier reinforced concrete design with Altair S-CONCRETE and Altair S-CONCRETE multi-story designer. So bear with me for the next couple of minutes and hope you enjoy this presentation. So we will begin talking about what is S-CONCRETE. Many of you might be already familiar with it, but just to summarize, and for those of you who don't know it, S-CONCRETE is a very powerful reinforced concrete section designer. So everything that you input into the interface, it's very easy. You can, with a couple of clicks, get familiar with the software and you will be executing design of concrete beams, columns, and walls in no time. Additional to this, very important, which is why most of us design with these type of tools, is to have support for international design codes depending of where we are. So S-CONCRETE can provide you with the instantaneous code utilization results depending on these particular codes and utilizations. So this is all part of the section designer, and after you have executed a certain design or utilization, you can explore the detailed interaction diagrams that are produced after creating your section. All of this is summarized in comprehensive design reports that will always tell you what the engine design is doing and what it's comparing it to. You can add up to thousands of loading conditions per section, up to 32,000. So you can go all the way and load your sections as much as necessary, right? With different load cases and combinations. So all of this makes S-CONCRETE a great solution for quick and detailed evaluation of concrete sections one at a time, which makes it ideal for small to medium-sized structures. So now let's get into S-CONCRETE's interface. So this is S-CONCRETE's interface. So here on the left side, we have all of the different section types that S-CONCRETE supports. Here we have the different types of beams, like the T, the L, the rectangular beams. Then we have the columns, rectangular and circular. And also we have here the different types of walls. And the rectangular wall, that can be also an I-shaped wall, or a C, T, or L-shaped wall. So whichever we select, we can always edit its general dimensions and miscellaneous if we go here to the section dialog. In this dialog, we can edit its general dimensions, its clear cover, the material properties over here, and even the miscellaneous, such as the type of code where we are going to be code checking against. So for this example, let's go ahead and work with the ACI 2019 with the units set to metric, right? We can also select the bar type to American, and if we were to add a steel shape embedded into the concrete section, we can do it. We just need to select which steel table we want to work with, and then just select the steel shape that we want. So after that, we have created the general miscellaneous. You can also edit its geometry with just the click and drag feature here in S-CONCRETE. And if you are paying attention, you may have noticed that whenever we edit the geometry, these utilization radios on top are going to be changing. This is because everything that you add or change in this section, it's going to be automatically code checked. For example, if I add or remove a reinforcement with just one click, like here, left to add and right to remove, these utilization radios are automatically updated. I can do the same with the number of ties and even the distance between the ties. Now, what is important also is about the loading. So for example, I come here to the loading dialog and I have here my default loading scenarios. This is what every section it's loaded with, but I can always go ahead and just clear this and bring my loads from different analysis that I already performed. So for example, I have here already some loads from a different analysis that I run on a different tool in an Excel spreadsheet. So I can just go ahead and copy this information directly into S-CONCRETE. I paste it here, and then all I have to do is click on OK. Now I have these utilization radios that are very low, so I will probably just going to reduce the general reinforcement for all of these, as well as my ties. So now I'm going to take a quick look at the results. I have two different options. I can go here to report and I can see all the different engineering report information. Over here I have the general information about the building standards, the design aids, and then I have the section properties, the dimensions, the material properties, the quantities, etc. Now if I scroll down, I will see the different input loads, the ones that I just pasted, and then I get the factory design loads that we are doing the design with. If I scroll down, I will see the different results for the actual loads and the shear and torsion utilization as well. If I keep on scrolling down, I will see that, for example, I have this warning regarding the vertical steer area, which is below the minimum accepted. So if I go all the way down, I will see a summary of all the messages that I have. In this case, I know that it's regarding the minimum area of steel, but it's highlighting for me the clauses of the ACI 318 that we are not meeting as of right now. So I can just go ahead and increase a little bit the steel reinforcement to comply with this. Lastly, I can go into the actual diagrams. These diagrams are interactive, so you can click on any part of the diagram to see the values of the actual forces. And here we have the critical points as well. So as you can see, S-CONCRETE is a very powerful tool to design one by one sections. But now what happens when we have much bigger, much complex models where we have a lot of different stories and hundreds or even thousands of different sections for building, for example. This is where S-CONCRETE Multi-Story Designer shines, because it has a 5-step workflow that allows you first to import the analysis data, and you can choose which of these particular data can import. So different sections, different groupings, allows you to specify initial reinforcement by section type depending on your columns, your beams, your walls. Then you will get to refine these reinforcement to get preliminary checks, and if you want to change anything here, you can do it before generating the S-CONCRETE files for each one of the sections automatically. After you do this, you have the ability to perform a batch code check on all of the sections, and you can even go ahead and open each one of them individually to fine-tune and check on them before generating your detailed design reports, which will allow you to see and share these section reports for each one of them with many different formats depending on who you want to share with. So that's what we're going to talk about in the next couple of minutes. So we will begin with talking a bit about the structural model that we will use in this workflow. We have model building made of 31 different stories that has different concrete sections. We have 27 different wall sections divided in two types, two different geometries, rectangular and C-shaped, as mentioned through the 31 stories. We also have 12 column sections between three different section sizes: circular, rectangular, and square. So we have over 600 columns in this model. And also we have 5 different sections for beams. All of them are rectangular, but they have different sizes and requirements. So over with this, we have more than 900 beams. So as you can see, we have over 1,000 different members in this model. So all of that combined with 10 different load combinations makes up for a quite large model. So here is where Multi-Story Designer it's really powerful. So in the next couple minutes, I'll show you how to go from importing your model to refining these design groups, running the preliminary checks, and generating final code compliant designs using the trusted S-CONCRETE engine. So whether you're working on a mid-rise or a large-scale multi-story project, this workflow will help you streamline your concrete member design process. Now, when we're back into S-CONCRETE, we have here run, and we have the S-CONCRETE multi-story designer. So once we open this dialog, the first thing that we need to do is to select the Access database where we want to import our model. So I click here, and I have this ready to go Access database, which is the same that you will have access to. So click here and open, and once the model is loaded, you'll see that the multi-story designer automatically detects and categorizes the structural members, such as columns, beams, walls, and braces. Now, slope braces from ETABS can be treated as columns if needed, and shell elements can be recognized as spandrels, spanning horizontally like beams, or as piers if they are vertically like walls. So you can choose how to treat these elements for import and design, giving you control over how the multi-story designer interprets this model. Now let's talk about grouping. So ETABS groups can become section design groups in the multi-story designer for columns, beams, and braces. So this is useful when different elements in your model have different section names but share the same shape, size, and material. For example, you might group all corner columns together, or columns along a specific face of the building. So these groupings help rationalize the design process, allowing multi-story designer to apply consistent design checks across similar elements without needing unique section names in ETABS or your model for each condition. With your members grouped, you can apply filters to control what you see and what gets checked. So you can filter by section type, load combinations, spandrels, or piers. So you have different options for the load combinations. You can choose and pick what you want to import and what not. Let's just keep in mind that multi-story designer and S-CONCRETE only perform code checks on cool-based factory load. And if your model includes non-rectangular piers like this one, the Pier Shapes tool will become available. Here you can review and refine how multi-story designer interprets the shape, ensuring that it aligns with the valid wall section types. For example, here we have a channel E, and we have noticed that it aligns with the C type, and we can rename it if we want to, and here we can see all the information regarding which stories these types of section shapes have been So once that we've done that, it's now time to apply some preliminary design specifications by clicking here on next. It's processing and it's taking us into the next dialog by importing everything that we asked of it to import. So in the project design standards, we can select or change the design code that we're going to work with and even the var type. We can also select what we want to include, such as the columns, the beams, and the walls. Here, you can set up different criteria like slenderness limit, for example, for your columns, minimum code moments, and even allowable utilization. This is independently for columns, beams, and walls. So you can set up and change, for example, the var diameter. If you want to apply two different reinforcement coordinates to your walls, you can include your slenderness, your minimum moments, and for walls particularly, even add seismic parameters depending on the type of design code that you have selected. So once that I've decided, I can click here on Apply Design Standards. And now Multi-Story Designer uses the section shape, size, materials, and the ETCs groups to generate a list of sections. This process also performs preliminary checks for the different section types available. Actual compression and tension for columns and walls, and top and bottom moment capacities for beams. We see that it has been added and created. And here are the DCRs, or demand to capacity ratio that we were talking about. So now you can review and sort these results to identify sections that need attention. We can more quickly identify these if we toggle on the preliminary capacity results in the section's description. That way, we can begin by making targeted adjustments to reinforcement and design parameters. For example, we have here columns, beams, and our walls. Okay, so here we can see the description of each one of them. And for example, let's take a look at the beams. So for deeper refinement, you can split the section groups into subgroups by story or custom story ranges. So for example, here from story 1 to story 6, we can create it for each different story and or only for the selected stories. So this will help you better match reinforcement to actual member demands across the structure. We click here on create update for the selected design bin. Now you can sort this through the different stories. So MSD will recalculate the preliminary checks for each new subgroup, updating the DCRs and giving you more accurate design feedback before moving forward. Now we have three ways to edit the section data. So first, from the main screen, we can sort by the DCR, check the parameters, and edit directly from here. For example, then just click here on update. So this is a fast way to target problem sections without affecting other values. So second, we have the section form. Here, it's the most interactive experience. It's similar to S-CONCRETE's user interface, and it updates in real time the DCRs. For example, if you increase these DCRs are going to get automatically increased. Also the reinforcement and the geometry, even if necessary. You can also launch from here a new S-CONCRETE session or run a code check as well. Here you would have these code check results, and it will tell you whenever something is borderline, passing or not passing the code check. You can even run an S-CONCRETE session. Just remember that none of these changes done in this S-CONCRETE new session will be automatically saved to the MSD. After doing this, click on OK. And third, we have the table view. So we click here. This spreadsheet style tool gives you a full access to material, geometry, and reinforcement data. You can bulk edit using copy and paste features to export everything to CSV for external review and reuse. So when you're satisfied with the section parameters, you can move on to generating the S-CONCRETE files and set it up with a batch run. So I click here on next. And first, we need to choose which member types to include, our columns, our beams, and our walls. You can also select the load combinations that you want to work with, and then you can begin the batch processing here by creating S-CONCRETE files. Once complete, you can see that it has created a different folder for each type of sections. So you can view your results with each one of these S-CONCRETE files. If we were to click each one of these, it will just open up a new S-CONCRETE session for each one of the sections that we created. After creating those files, we can just click here on Run S-CONCRETE Batch to run a code check on all of these sections that we have just created for each one of the files. Once complete, we can click here on OK, and now we get the option to view the code check results and even create a report. You can view your results in a detailed tabular reports like this one. Here you have the information for each one of the SEO files, and you have here your code checks that are not passing. Here we have some warnings regarding torsion, regarding actual load and moment utilizations, etc. You can export this data directly into an Excel CSV file if you want to, and also you can export them into a different type of format with the create report utility, where you can create these full reports in PDF or HTML interface using the same trusted code check engine. For example, we can go here and we can add whatever types of sections we want. For example, I'm just going to go ahead with the walls report for do this faster. So if I click here on create report, I get this PDF with all the visual representation of my code check results for this particular model. And I have here each one of the sections, each one of the walls with my full code check capabilities and full code check utilization radios for all of those. And well, you can see that these reports are clear, complete, and ready for documentation. We can always go back from the batch screen and navigate to the view menu to access the updated design status for each section group that we have here. So we can, for example, select any member that didn't pass, and we can update the design parameters and then use the run code check button to verify the changes. We can update the design parameters, for example, increasing this diameter, and we can just update the design standards for this. We can apply this, click on OK, and then update for the design data, and so on. So as you can see, this gives you a complete control over the design lifecycle. So back on our reporting capabilities, once that we've run the concrete code checks, we also have the ability to run the batch utility in order to create full detailed reports for each one of the concrete sections in a determined location, right? So I've already have here preloaded some of my files, and I have pointed this location to the specific sections that I want to create the reports for. So all I have to do is to select which kind of batch processing I want to do, code check, click here on Run Batch. I click in yes, and now it's running the code check for all the sections contained in the folder of the location that I just threw at it. Once it's finished, you can see it took a couple seconds. I can click here on report options to adjust what I want it to report, and I can also create here directly the report, and it will be a complete summary of all the different sections contained in that folder with the code's utilization as displayed here. I have concrete section, code check results, and you can see here a summary of all the utilization radios for each one of the sections contained in that particular folder. If I scroll down even further, I can see a detailed report on each one of them with loading combinations, loading factors, and etc. So as you can see, the multi-story designer brings together everything, like importing from your model, grouping and designing the concrete members, applying your standards, and running your code check. Also generating your reports, all integrated into one workflow. So by leveraging S-CONCRETE's proven engine, the multi-story designer delivers a single source of truth for concrete design, scalable to projects of any size. So that's it for today. Thank you all for attending this short presentation. I really hope that with this you are now able to get the most out of S-CONCRETE multi-story designer. Thank you for coming, and I will see you on the next one.